So for problems 5 and 6, we're going to find the derivatives of the given functions. In 5, we're given this function here. Now what I'm looking at is a product, right? There's the first factor and the second factor. So I'm going to use the product rule, derivative of the first times the second, plus the first times the derivative of the second. So let's start it up here. So f prime of x is going to be, right, the derivative of the first, about 12x squared, times the second, e to the 4x plus 2. So here is, I'll mark it down what I've done. Here's the derivative of the first times the second. Now I need plus the first, which is 4x cubed, times the derivative of the second. Now the second is that exponential function. And we know how to differentiate an exponential function. It's the function itself, e to the 4x plus 2, times the derivative of the exponent, which is 4, right? The derivative of that exponent is just 4. So I'll mark down what I've done. Here's the first times, that's the derivative of the second. Now, it is, right? Do you believe it? It is the derivative of the second. What we have here is the first, which is 4x cubed, times the derivative of the second, and the second's an exponential, so it's the function itself times the derivative of the exponent. So we've got the calculus part done. Let's put it together with some algebra. So f prime of x, not much we can do with that first term. 12x squared e to the 4x plus 2. But in the second one, we can do this. We can take that 4 times the 4, getting 16. Oh, let's do it all in one color here. We're going to get 16x cubed, and then that e to the 4x plus 2. Now we can actually do a little bit better here. We can factor here, right? F prime of x is, what's common here? Well, between the 12 and the 16, there's a 4 common, so we can take out a 4. Between the x squared and the x cubed, there's an x squared common, so we can take out an x squared. And then there is this e to the 4x plus 2 and an e to the 4x plus 2 on each one, so we can take that out, e to the 4x plus 2. And then if we take all that out, what's left? Well, let's see. There was a 12. We took out a 4, so there's a 3 left, right? 12 divided by 4 is a 3. There was an x squared. We removed it. There was the exponential. We removed it. So I think all we get here is a 3 plus, now what do we get over here? 4 times what is 16? So 16 divided by 4 is a 4, so we'll get a 4 there. There were 3 x's, right, x cubed. We took out 2, so there's an x left. And then there was that exponential, but we removed that. So I think we've got it all here. So I'm going to claim now that this is the derivative and in simplified form. Oh, this number 6 looks nice, right? E to the 9x, natural log of 9x. So we've got exponentials and logs together. But globally, I'm seeing a product. There's the first factor, there's the second. So I'm going to use the product rule, right? Derivative of the first times the second, plus the first times the derivative of the second. So let's go here. F prime of x is going to be, now the derivative of the first. The first is this exponential. It's the function itself, e to the 9x, times the derivative of the exponent, which is that 9, times the second, natural log of 9x. So here it is. Here is the derivative of the first times the second, plus the first, e to the 9x, times the derivative of the second. Now the second's a log function, and log functions go like this. It's 1 over the argument, so it's 1 over 9x. Remember, the argument is what you're taking the log of. I'm taking the log of 9x, that's the argument. So it's 1 over the argument times the derivative of the argument. So this is times derivative of the argument, which is 9. So I'll mark what I've done here. Here is the first. Here is the derivative of the second. So we've got the calculus done. Now let's simplify it using some algebra. So let's see. In the first case, I think we're going to have, I'll just write it with that 9 coming out first. E to the 9x ln 9x plus, what happens here? Well, the 9's will cancel. And it looks like we'll just get, what do we get here? We just get e to the 9x times 1 all over x. So it looks like we're going to have e, oh, let's get the same color here. We're going to get e to the 9x over x. So I think that's probably good enough, but, well, what did I write here? So here's a derivative here. Let me just write again. 9e to the 9x ln of 9x, probably don't need those parentheses, plus e to the 9x over x. You know, this is probably good, but in some cases, we may want to get this over a common denominator, which is x. So a common denominator, if I write this denominator as x, I'll have to multiply over here. So I could rewrite this like this. F prime of x equals 9. Now multiply it by x. E to the 9x ln 9x plus e to the 9x. All of that is over x now. And then I can factor out that e to the 9x. So a little bit more than maybe we were thinking at first. So I can write this now as, if I factor out that e to the 9x, what's left? 9x, natural log of 9x, plus 1, all of that's over x. There's another way to write it, more simplified, but you know, this is probably good enough, but it depends what's going to go in that answer box.